Okay, here we go. This is a fairly full lesson for this class, so you need to stay on task here. Adding, subtracting polynomials. So most of what we're doing now, from now until the end of March, is with polynomials and quadratics. Which quadratics are really just one kind of polynomial. That's the last big unit that we're doing. So adding and subtracting is today, multiplying is tomorrow. We don't do divide in this class. Oh, just a second. These are the ones I copied. Okay. You're welcome. Okay. Here we go. Right? So polynomial, the word means, poly means many. Term, the meal, no meal, means terms. So many terms. Right? That's literally what polynomial means. Right? By terms, we mean things like this. Right? 2 times x times y, that's one term. I mean, it's got many factors. It's got 2 and x and y, because what are factors? Factors are things that multiply together, okay? So this is just all one term. If there's a plus or a minus in there for addition or subtraction, that splits it into multiple terms. So but just one term in a polynomial, it could have variables in it, could have more than one variable, could have a number in front. The number is called a coefficient. We're going to do the FOIL thing in here. Yeah, eventually, not today. All right, so polynomial, many terms. The variables of polynomials, the exponents are only whole numbers. Right? So what are whole numbers? Well, what's the first whole number? 0, right? So that includes 0. Well, if you have a variable to the 0 power, what is it? It's 1, right? By properties of exponents, that's 1. So usually, if you have a term, let's say here's another term that I'll add to this. I mean, that has a variable. The variable could be x to the 0, so you don't write it, right? So you would say that that could have a. We're going to talk about degree in a second, but that has a degree. You just have to take into account that that's like a variable raised to the 0. Okay, so polynomials have terms separated by pluses and minuses. So that's 2 terms the way I wrote it. The number in front, vocabulary word, coefficient. Right? That's what we say for the number in front. Okay, so are these polynomials? So why would that one not be a polynomial?
Not a plus or minus.
No, not for that. What did we say the exponents have to be? They have to be whole numbers, right? So we can't have an x, right? So that is a no, right? Because the exponent is not a whole number. So how about the next one? Is -3 a whole number? No, because the whole numbers start at 0 and only go positive, right? So that's not either. That's no, negative exponent. So I can actually say no for the same reason, right? The exponent is not a whole number. Okay, how about the next one? Okay, there's only one variable term, and it's got an x, and what's the exponent on that x? It's a 1. Is 1 a whole number? Sure. Okay, how about this one? Yeah, I mean, there's no problem with having the coefficients or the constant term be fractions. It's the exponent that can't be fractions. Right? So both of these are yeses because all the exponents are whole numbers. So that is a yes. and a yes. Right? And again, when you don't see the exponent, that means that it's 1. Okay. So the standard form, when we write a polynomial, is to have the highest exponent to the left, and then in decreasing order of the exponents. So it should be the highest power to the left, the lowest or constant all the way on the right. Right? There shouldn't be any parentheses, so like you've got to just go do some simplifying or anything like that. Yeah. Yeah, it doesn't matter the coefficient. Well, no, it doesn't matter. Okay. So standard form means you're going to simplify. If there's any multiplying to do, distributive or anything like that, you do it, and then you put them in order, highest power to lowest power. Yeah. We're going to get to that when we do the adding and subtracting, right? Because I'll just save it for when we get to that, a couple slides from now. All right, the leading coefficient is whatever's the coefficient of the first term. When you put it in standard form, whatever is the first term, look at the number in front, right? That's the leading coefficient. So this one here, not standard form, because the highest power term is on the right. This would be in standard form because it's got the highest power term here, and then it goes down, 3, 2, 1, 0, right? Now, once I put it in that form, when we say the leading coefficient, that means the coefficient of that first term, 4. Okay, right. Okay. So write in standard form and identify the leading coefficient. Okay, so how am I going to write in standard form? Remember, what's got to be the first term you write? Okay, which term is that? Okay, it's got to be, you got to take the negative with it, right? Because it's actually got a negative sign on it. So we're going to say negative x to the third. Okay, which term should be next? The 15x, because that's the next highest power of x. And it's a plus. Okay, and then the plus 3. Could you see the negative right here? That is the sign of the term. I mean, if you want to, you could do it like this, right? We know what the definition of subtraction is. 15x plus negative x to the third plus 3. I mean, if you think of it like that, then clearly the first term is negative x to the third. Okay, now what's the leading coefficient? Because we rearranged it. We're saying to write it in standard form means rearrange it. I mean, ultimately, what did we do to go from this line, the first one here, to this one here? We switched the order of 2 terms. Okay, which property says we can do that and it doesn't change the value? Neither one. Commutative property says you could change the order. So we didn't do anything to change the value here. We just wrote it in a way that it's the standard. It's what you expect when you look at a polynomial, right? So that's all we did. Use a little commutative property to get that highest exponent on the left, and then the next highest in the middle, and then the least on the right. Okay, what is the leading coefficient? You know, what is the number that goes in front of that term? And it's -1, right? So that is the leading coefficient. Good. Melissa? Good. Slow me down if I go fast. So try that one. Write in standard form and identify the leading coefficient. Okay, so in standard form, what should have been the first term? The -2y squared would have gone first, right? Okay, and remember, what we're ordering this by the exponents, right? The size of the exponent. So we want the highest exponent on the left, the next after that, and then you keep going until you get to the lowest. So which is the next highest power of y? 5y. Well, if you've confused like the constant term, again, you could think of it like this. I could rewrite this like 9y to the 0 plus 5y to the 1 minus 2y squared. Because what is y to the 0? It's just 1 anyway. So in that effect now, we can definitely put these in order of the exponents, right? The highest exponent was a 2, so that went first. The next was 5y. And the next is 9. Okay, what does that make the leading coefficient? Right, the leading coefficient equals -2. Right, that number right there. Whatever's in front of the highest power term. So polynomials can be classified by their degree and by their number of terms. By number of terms, these are vocabulary words here, right? Monomial, you know, the prefix mono means 1. So one term is monomial, something like 2x. 2 terms is binomial. So know any words that start with bi and the bi means 2? Bicycle. Okay, so what would you expect it to be when you have 3 terms? Trinomial, you know? I mean, there's probably prefixes even for 4 terms, but generally, once it gets to 4 terms, you just say polynomial, right? They're all polynomials, right? But if you're classifying 1 or 2 or 3, you use the words monomial, binomial, trinomial. If you get to 4 terms or more, just say polynomial. Fill in the mess. That takes me a while to get through all that stuff. Any word's fine. Any word's fine. I got text from other classes and okay. Good. Okay. Good there. Good on this side. Kaylee's on. Okay. The degree of any particular term is the exponent, the size of the exponent, right? So if you have 2x, then the exponent is 1, the degree is 1. Right? Whatever is that power right there, that is the degree. X squared is 2, x to the third is 3, x to the fourth is 4, and so on, right? Now, we have some words that we use for these that are really part of the vocabulary that we should know. Like, when it is degree of 1, that's called linear. Right? That means if we graphed it, the shape would be a straight line. When the degree is 2, that's called quadratic, right? And we will get to that in this unit. What is the shape of a quadratic function? The others we're not going to get to in this class. But we do need to know that the degree, that usually if you have an x to the third, you're going to say the degree is a cubic. And an x to the fourth is called a quartic. And, you know, above a certain level, I mean, we don't know the words. There is one that goes in there. What do you think x to the fifth might be called? Cubic? Quartic? Quintic. Quintic. I mean, quintic is not a bad one. But usually at a certain point, you just say like 6th degree, 7th degree. We don't really have a word for it, or at least not that we use commonly. But definitely, like the first 3 we should know. Linear, quadratic, cubic. I mean, we've already talked about cubing things, right? So that makes sense that that's an x to the third. The quadratic, you know, that might be kind of a new word. It does actually mean squared, you know, just not in English. Don't know about, well, I mean, like in Latin, Italian, quadrato, I don't know. What do you call it in Spanish? How do you say squared in Spanish? Okay. So anyways, I mean, it is like, in a way, it's like saying squared. It's just not in our language. Until you just understand the word, and then it does mean that. Very good. So let's classify these by their degree and number of terms, right? So by degree, what would you call this one? It's quadratic. And how many terms does it have? 3. 1, 2, 3. Remember, terms are separated by pluses and minuses, so that's 3 terms. So there'd be a quadratic something meal. 3 terms? Trinomial, right? So this is the quadratic trinomial. What about the second one? What's the degree? Yeah, I mean, degree is 3, so we would call that a cubic. And how many terms? 2. So what's the word for 2 terms? Binomial. Okay, now by degree, what is a constant? No, linear would be if it was x to the first, but it's not x to the first. It's actually like an x to the 0. So we would just have to say the degree is 0. Well, it's 9 to the first, but it's the exponent of the variable that counts. So the degree is 0. A constant term has a degree. It's 0. Okay, classify that one by the number of terms. What do you call it when there's only one term? What was the prefix for 1? Unomial? No. Monomial. Right? So degree is 0, monomial. That's what constants are. You always got to think of constant as the lowest degree term. Right? If it has a constant, that's what goes all the way on the right. Okay, now we get to the adding and subtracting. Right? We did some of this in the very beginning when we were doing, I think it's actually in like the second lesson, when we did some combining like terms. And what did it mean to say combine like terms? Well, when can you add them? They have to have the same variables raised to the same power, right? And then if they do, how do you add them? I mean, for example, we did this before, but let me write a simpler. What if I have 2x plus 3x? What does that become? What is 2x plus 3x? 5x, right? They're like terms because they both have x to the first. And the way you add them is you add the coefficients. So that is 5x. Okay, well, we're going to have the same thing up here. First of all, do these parentheses do anything for us? Are they changing signs of anything? And the answer is no. So, I mean, if you're, don't let the parentheses confuse you in this kind of, in a sum and in addition. So let me write it right here. 2x to the third minus 5x squared plus x plus 2x squared plus x to the third minus 1. Okay, now first, if I'm going to add these up and write my answer in standard form, which is the highest power that I want to make sure goes all the way on the left? 3, okay? So how many x to the thirds do we have? We have 2x to the third there and 1x to the third there. How many x to the thirds? That's 3x to the third. Right? What's the next power of x you've got? You've got x squared here, and you've got x squared here. So negative 5x squared plus 2x squared. Add the coefficients. Right? That should be like negative 5 plus 2, which is negative 3x squared. Okay? Do we have an x to the first?
Yep.
How many? You just have the one term, so that goes next. And then we have a constant. Minus 1. There you go. So adding polynomials is adding like terms. You know, like terms have the same variables raised to the same power. When you add them, you add the coefficients, but don't change the power of x. Right? If you're adding x to the thirds, it stays x to the third. Right? Don't try to change that into x to the sixth or something like that. Okay. So we'll do this one together. So in this one, the plus isn't going to make any difference. So I know that. I'm not going to take a step and write it without the parentheses. I'm just going to go ahead and add these two, right? What's the highest power term of x that I need to put all the way on the left? It looks like we got 2 quadratic terms, right? How many x squareds are there? There's 3 there, and there's 1 there. So how many are there? 4x squared. Okay, next, do we have any x to the first? And the answer is yes, right? So how many x's is that? It's 1x plus 4x plus 5 times x to the first. Okay, what about the constants? There's a negative 6 there. There's a positive 10 there. Plus 4. Done. So that's how you add polynomials. And you should always leave your answer in standard form. Right? Highest power to the left, decreasing order of the exponents. Okay, Lily? Are you okay? Okay. All right. Okay, so try that one. To add them up, the variables have to be the same, and the exponent has to be the same. So what's going to be the highest power term in this one?
3x cubed.
Yeah, there's 1 x to the third term, so we're going to write that all the way on the left. Okay, what about the x squared? How many did you see?
So 5x.
5x squared plus 4x squared makes 9x squared. Don't change the exponents. Okay, how about the x to the first? Yeah, this first one wasn't actually written in standard form because they didn't combine like terms first, but I didn't. So 4x minus 2x? 2x, right? 4 minus 2. Okay, and then do we have any constants? We got a minus 6. Okay, so that is, add those two, put them in order of the exponents. Highest degree, highest power to the left. I mean, so far this is not hard, right? A little bit of vocabulary. So when you subtract polynomials, here's the deal. With subtracting polynomials, the parentheses make a difference. You have to be careful because that's like saying you're multiplying everything in this second polynomial by -1. Okay, what does that do to the sign of all that? It flips it. So when you get a problem like this, you should really take a step and distribute that negative onto every term in the second polynomial. So I would write it like this. 4n squared plus 5. Okay, now minus a negative makes plus 2n squared. Right? I'm distributing here and here and here. Negative 2n and negative times negative 4 is positive 4. So take a step and basically turn it into an addition problem by distributing that negative. And now we're going to combine like terms just like we did before. Right? So what's the highest power term going to be in this polynomial? It's going to be 6n squared, right? Okay, next. The minus 2n is the next highest power of the variable. And then you got a 5 plus 4 is 9. Everybody good with that? Alyssa, you there? Alyssa. All right. Here we go. Okay, how about this one? Okay, take a step, distribute the minus. That's going to give us minus 3x squared plus x plus 8. Right? Take a step and get rid of the parentheses by distributing the minus. Right? I mean, some of you won't do that, okay? And you can still get this right if you don't take that step and do it. You got to be careful, right? 4x squared minus 3x squared. Negative 3x minus negative x. I mean, you can get that right, but we can both tell you that later on in higher classes, this is still a mistake that students are making all the time because they don't take that last step and distribute the negative, and it always leads to a mistake. So, okay, now that I've distributed the negative, what's the highest power term that goes on the left? 4x squared minus 3x squared is 1x squared, right? Negative 3x plus x minus 2x. 5 plus 8 plus 13. Okay, what is the degree and classify this one by degree and number of terms. What do you call it when it's squared? Quadratic. And it has 3 terms. Trinomial. And by the way, what's the leading coefficient? 1. Okay. So try that one, and then we're done. You can check your work up there. You get it? Okay, so time to wrap up. Okay, hurry up. Gotta put up the homework. Wait a second. Wait. I'm waiting for somebody to finish. That's the homework.